We will now discuss the solution of a problem from the section Sets, Relations and Functions. And the problem is based on 1 and onto properties of functions. And this problem has appeared in JEE Main examination held on 25th July 2021 in the shift 2. The problem is, consider the functions f from the set A to set B and g, a function from set B to set C where A, B, C are subsets of the set of real numbers such that G compose F whole inverse exists, then the four options are given to us. Option 1, F is 1, 1 and G is on 2. Option 2, F and G both are on 2. Option 3, F is on 2 and G is 1, 1. Option 4, F and G both are 1, 1. Let's now discuss the solution in detail. We have A, B, C are subsets of the set of real numbers, and we have functions f from A to B and G to G from B to C. And we are given G compose F inverse exists. What is G compose F? G compose F is a mapping from A to C, and it is given to you that G compose F inverse exists when the inverse exists if and only if it is bijective. This implies G compose F inverse exists implies G compose F is bijective. What do you mean by bijective? It is both 1, 1 and onto. That is, G compose F is 1, 1 and onto. Now, we have the function G compose F from A to C, and let us take down G compose F is 1, 1. So, it has the two properties, but we have taken the first property. Then, I claim that F is 1, 1. That means, if G compose F is a mapping from A to C and G compose F is 1 to 1, then F is 1 to 1. So, this is what I want to prove. To prove F is 1, 1, what do we do? Fx is equal to Fy, then I will prove x is equal to y. So, Fx is equal to Fy implies x is equal to y. If I can prove, then F is 1, 1. So, Fx is equal to Fy. So, then operating G on both sides, G of Fx is equal to G of Fy. Now, one may say they may not be equal. Then in that case, G is not a function. So, if not, that means if G of Fx not equal to G of Fy, then G is not at all a function. Why? Because it is mapping two equal elements Fx is equal to Fy onto two distinct images, that is G of Fx not equal to G of Fy. That means two equal elements. That means two equal elements are mapped to two distinct elements, two distinct images. So, G is not a function. Therefore, G of Fx not equal to G of Fy is not true. Therefore, G of Fx is equal to G of Fy. That means whenever f of x is equal to f of y, then G of Fx is equal to G of Fy. So, what is G of Fx? G compose f of x is equal to G of Fy, G compose f of y. But what is given to you? G compose f is 1 to 1. So G compose f of x is equal to G compose f of y, and G compose f of f is 1 to 1 will imply x is equal to y. So this is so. Why? Because G compose f is 1, 1. Thus, we have proved fx is equal to fy implies x is equal to y. So this shows that f is 1 to 1. So when G compose f is a mapping from A to C and G compose f is 1 to 1, then f is 1 to 1. So that's what we have proved. So let's proceed for the next step of the proof. We have the functions f and g, and we have the function G compose f from A to C, and G compose f is onto. That is the second property we have taken. We want to prove that G is onto. So this is a general result also. G compose f is a mapping from A to C, and G compose f is onto, then G is onto. That's the general result. So to prove that G is onto, what we will do is, G is onto means G is from B to C. So to show G is G from B to C is onto, then we have to prove every element small c belongs to capital C has a pre-image in capital B. Then G will be onto. So we will take let C be any element of capital C. So you are here, and you know G compose f is onto. What do you mean by that? For each C belongs to C, there is an element A, that means that C belongs to C as a pre-image. That is, there is an element A belongs to capital A such that G compose f of small a is equal to small c. So since G compose f is mapping from A to C is onto, there exists an element A in capital A such that G compose f of A is equal to C. That is, G of f of A is equal to C. Now see, A is in A now. A is in A, then f will send A to f of A. That will be in B. So now you see f of A is a B. So for this C, for this small c belongs to capital C, you find a small a in A. For that, you will find its image f of A which is in B. So you have found an element of capital B. So let B is equal to f, small b is equal to f of A which belongs to B. Then G of f of A means G of B is equal to C. So thus we have found a pre-image, that is, for this C belongs to capital C, we have found a pre-image small b in capital B. So thus for each small c belongs to capital C, there exists an element B is equal to f of A that belongs to B such that G of B is equal to C. This shows that G is onto. Let's now summarize what we have proved. We have the three sets A, B, C which are subsets of R, and F is a mapping from A to B, and G is a mapping from B to C, and G compose F inverse exists. This is given to you. Then it implies G compose F is bijective. That means G compose F is 1, 1 and onto. So now we have taken G compose F is 1 to 1. Then we have proved F is 1, 1. That is our claim 1 and what we have proved in the last slide. G compose F is onto, then G is onto. This is what we have proved the above. So thus, what is that we have proved? So we have proved F is 1, 1 and G is onto. So that is the option 1. So our answer is option 1 is true. That is, when G compose F inverse exists, then F is 1, 1 and G is onto. So the option 1 is true. That is the discussion of the problem from the section sets, relations and functions, and the problem is based on 1 and onto nature of the functions. I hope that you have understood the solution of this problem and go on working out some more problems on these lines from your standard textbook. I wish you all the best. Thank you.